Welcome to yet another question on Newton's second law of motion, and the question says, the figure below shows two masses M1 and M2 and the kinetic friction of the bench is 10 newtons. So we have got this bench and then we have this mass that is connected to this mass by this rope. And this is 5 kg, this is 2 kg. So from this, we have got this to say we are told to say the coefficient or the kinetic friction of the bench, which is this bench, is 10 newtons. So the first question is find the coefficient of friction, 2, the acceleration of the system, 3, the tension in the rope. So here we are going to begin with this one, the coefficient of friction, of which it is just this mass which is encountering this kind of resistance. So we have this one, we have this is the bench, which is the surface, then we have this mass, and then since it is going in this direction, there is this friction force here, and then we have mg here. This is the tension in this direction. Then there's also a normal force. Okay. So from this, we know that friction force is given by mu n. This is the formula for friction force. Now, let me just erase this. This one from Newton's laws of motion, we know that summation of forces in y must give us 0. So n minus mg must give us 0. This is positive, this is negative. So n is equal to mg. And since this is the m1, so this will be, okay, mu is equal to this one. So this one is going to be mg. This is 1. So we have mu m1g. So from this, we know that the friction we've been given to say friction is 10 newtons. If we want, we can just go direct by saying friction force is equal to 10 newtons. We know that that one friction force is given by this, of which we know. So this one will give us 10. So from this, we can write by m1g. This and this will go, and we're going to have mu. This will give us 10 over m1, 5 times 9.8. What we are going to get is 0.2048, which can be rounded off to 0.2 as the coefficient of friction. The second question talks about finding the acceleration of the system. This one, let us resolve for each mass. For M1, we have this. We have this one as tension. Then we have this one as mg. Just a diagram that we are just from erasing. Then this is Fr. And of course, this on top here we have the normal force. So summation of forces in X must give us ma. In XO we have T, which is this one T, minus Fr. This will give us ma. So we can call this as equation 1. Or maybe we can go further. T is equal to T minus mu m1g. This will give us m1a. Let us call this equation 1. For equation number 2, we know that summation of forces in y must give us 0. That is for m2. We have got this one, so we have m2g then this is tension. So we have M2G coming down. Okay, so this one will be positive, this will be negative minus T, which will give us M2A. Let us call this equation 2. So this is equation 1, this is equation 2. Now we can eliminate some value. We eliminate some value, which is here the variable, or we can eliminate some variable, of which the variable that is easy to eliminate is T. We have this one and this one. So we can eliminate by adding. Add 1 and 2. Equations 1 and 2. So from the left hand side, we have this one from equation 1. We have T minus mu M1G. Then from this one, from this equation, we have plus M2G minus T. This will give us M1A, that from this one, then from that one, plus M2A. So this one and this one, this is positive, this is negative, so this can go. And then we're going to have M2G minus mu M1G. This will give us, so this is common, A is common, we can factor it out, M1 plus M2. From this, we know that this is a friction force and it is given by 10. If we want, we can plug in the value we found for 0.2, then we will follow everything else. But we can also just put it like that, it's fine. So we can divide it through by M1 plus M2, even here, this and this will go, and is equal to G is common, we can even factor it out. So we have G M2 minus mu M1 over M1 plus M2. So from this one, we have, so G is 9.8, M2 is 2 minus 0.2 times M1, which is 5, over this one, we are going to get M1, which is 5, plus 2. This one, evaluating this, we are going to get the value for acceleration will be 1.37, which can be rounded off to 1.4 meters per second square as the value for acceleration of the system. Now the last part, demands us to find the tension. So this is B. The tension in the system, we are going to make use of one of the equations. Okay, so we can make use of one of the equations by even this one. We can use this one or any equation among the two. M2G minus T is equal to M2A. So this one can come this side, and it is going to be a positive one. M2G, this one will come this way, and it will be negative. M2A. This is going to give us T. So that we will putting in the values. Putting in the values of T is equal to M2. We have, so since it is common, we can even say this, M2G minus A. So putting the value for M2, it is 2 times 9.8 minus 1.4. Here, what we are going to get is 16.9 newtons as the value for tension in the rope. Thank you so much for watching the video.